Let's try to evaluate the given integral, the integral of e to the power of 2z dz from 1 to 1 plus I. Okay, take note here, we are on complex numbers, and this 1 plus 1 plus I is along a certain path C. Okay, so it's not necessarily the same as understanding the definite integral in real context, but the idea is already the same together with the rules that will be applied. It's just that the only difference here is that we're talking about complex numbers, the path or the contour is different from the endpoints of 1 plus 1 plus I. Okay, so we'll have here the integral of e to the power of 2z dz 1 to 1 plus I. Now, this is in the form of e to the u du. And we know that the integral of that is e to the u itself. But we need to be assured first that the du is the derivative of your exponent. Our exponent here is 2z. So if we're going to let u being 2z, its derivative must be 2dz. We need to add a 2 here. So basically, we're going to multiply that with the coefficient of 2. So this is equivalent to the integral of e to the 2z 2 dz from 1 to 1 plus I. But take note, since we added 2 here, we need to also add or multiply here 1/2 to neutralize that change, still returning to the original expression. Please do not forget that perspective. Now, this is already in the form of e to the u du, so we simply again take the e to the u itself. This is now 1/2 times e to the 2z as itself. But we are to evaluate that from 1 to 1 plus I. Okay? So, as to continue, you will have here 1/2 e to the power of 2, and your exponent must be 1 plus I minus 1/2 e to the power of 2 times 1. Okay? Take note of that. Which would give us the result here, 1/2 e to the power of 2 plus 2i minus 1/2 e to the power of 2. Okay. Now, before we continue with this, take note that when we say an exponent of 2 plus 2i, hopefully you can clearly see that, we can rewrite it in this manner, 1/2 e to the power of 2 times e to the power of 2i, because we are just adding exponents of the same base, minus 1/2 e squared. I'm doing that because I can factor this entirely out. Okay, so what we have here is simply 1/2 e squared times e to the power of 2i minus 1. Okay, so this is one of the versions of the answer where we factored 1/2 e squared from our expression. But of course, there are also some expressions that will allow us to simplify this further, because in Euler's form, if you have e to the power of I theta, this is equivalent to cosine of your theta plus I sine of theta, where your theta is the factor or numerical coefficient of your I. This has 2, so we can even rewrite this further. Again, this is already good, but we can also write this further as 1/2 e squared times, writing that in this manner, cosine of 2, as that is our theta, right? Cosine of 2 rather, plus I sine of 2 minus 1. This is also another form, considering that this expression with exponent of I can be written in Euler form in this manner. Okay? So these two are all the acceptable answers, or you can even write that as e squared over 2, and that's already good. Okay? This is the result for this given item. Thank you very much for watching.